Okay guys, so today our topic is gonna be exponent. Okay, so today our topic is gonna be exponents and the polynomial. Okay, so today our topic is gonna be exponent and the polynomial. So this is kind of like a really important chapter, a kind of really important chapter, right? So therefore we got like tons of really important information before we're doing any question. Okay, so those are the, we got some really important property, and then we got some really important property over here. Okay, and we also got some really important definition in order for us to to get better understanding what is exponent and the polynomial. Okay, so let's get started with some important property first. Okay, so those uh, the property over here, all you have to know it, and you also need to know how to apply them. Okay, you need to know it, you also need to know how to apply them. Okay, so let's get a start. So important property, okay, over here. So at the beginning there is actually some condition for those properties. So we got totally 5 property over here, and we got some condition for those property. So you can see over here, for any, right, for any real number, right, for any real number a and a positive integer m and n. So this is the condition. So for any is those any real number a and positive integer. Those are the condition for a, m, and n. Okay, so you want to make sure, like, those conditions are, you have to keep in mind when you actually apply it. Okay, when you actually apply, you have to keep in mind, because if it is not the condition, if it is doesn't meet the condition, then you are not able to perform those really important property. Okay. So let's move into the property 1. Okay, let's move into property 1. I will try to make sure the condition. So this is the condition. Okay, so this is the condition. I will try to keep make sure the condition is, most of the time is you can see it. Okay, so for the first property, you can see over here we got a to the power m multiply a to the power n, and it is equal to a to the power m plus n. I think this property everyone is really familiar, right? And we got one example over here. The example over here is 2 to the power 5 multiply 2 to the power 7, right? So it becomes 2 to the power 5 plus 7, right? And then it just becomes 2 to the power 12, right? So it is 2 to the power 12. So this is the example for property 1. Excuse me. Okay. And we got a property. Let's look at property 2. Okay. The property 2, what we have over here is a to the power n over a to the power n is equal to a to the power n minus n. And what we have example over here is 2 to the power 12 over 2 to the power 7, right? So you can see it over here. We got a as 2, and 2 is actually a real number, right? And then we got m as 12, right? And n as 7. 12 and 7 are both positive integer, so the condition has been met. So you are actually able to perform it, right? You get it, right? So what I mean is that over here, let me repeat one more time. So we got a over here is 2, and 2 is real number, right? So we hit the condition for a, and then we see m is equal to 12 and n is equal to 7. 12 and 7 are both positive integers, so you know the condition has been hit. So you know, so we are able to apply those properties, right? So what we have over here is 2 to the 12 minus 7, right? And which is 2 to the power 5, right? So it is 2 to the power 5, right? 12 minus 7 is actually 5, right? Okay. So let's look at property 3. I will try to make you understand the condition again, okay? So here we got property 3 as a to the power, we got bracket a to the power m, bracket power to the power n, right? And it is equal to a to the power m multiplied by n, right? And we see the example. The example over here is bracket 2 to the power 3, bracket to the power 2, right? And then you can see over here a is equal to 2. 2 is a real number, right? And then we got m equal to 3 and n equal to 2, and 3 and 2 are both positive integer. So you know we met the condition, right? So we are actually able to solve it. So as the property say it, we got 2 to the power 3 multiplied by 2, right? So which is 2 to the power 6, right? So it is 2 to the power 6, right? And let's check the condition one more. I think maybe let's check the condition one more time, okay? I hope everyone does understand it. So for property 4, what we have is bracket a b bracket to the power m, and it is equal to a to the power m b and multiply b to the power m, right? Okay, so we can see the example over here. Over here is actually bracket 3x bracket to the power 3, right? So what you basically say about that is like we got a variable, right? So we have a as a real number, right? So a is a real number, right? So a is equal to 3 and 3 is a real number, right? And what you can see is just actually, yes, you can see actually there's another variable x, right? So let me repeat this one more time like this. So we have a equal to 3. So 3 is a real number, right? So that's meet the condition, right? And then you can see we have an x and we have a variable, right? So that is just the value, that is just a variable, right? And then we got m equal to 3, right? So m equal to 3. 3 is a positive integer, right? So you know we actually hit the condition. Even over here we don't have n. We don't actually have an n, but that's okay, right? So that's okay, right? So I mean, the condition, it just want to make sure, like the condition doesn't say we have to have all the variable, right? Doesn't say we need to have m and n, right? So what I mean over here is like, we got 3 bracket 3x to the power bracket to the power 3, right? Bracket 3x bracket to the power 3, right? So we actually does hit the condition because over here a is equal to 3 and 3 is a real number, right? And then x is just a variable, right? So variable, there's no condition for variable, right? There's no condition for variable. And then we got m equal to 3, and 3 is also a positive integer, right? So actually, we actually are able to using the property. We are actually able to use the property 4, right? Okay. Maybe you ask me why there's no n over here. I mean, we it's true, we don't have an n, right? So since we don't have an n, then there's no requirement for n, right? There's no requirement for n. there's no requirement for n, right? So now things make sense, right? Okay. So what you can see over here is that, let me simplify. Let me doing this step by step. Okay. So we have as the property say it, we have 3 to the power 3 and x to the power 3, right? And remember before, 3 to the power 3 is actually 27, right? And so it's going to be 27 x to the power 3, right? Okay. Okay, so that's the example for property 4, right? So let's move into the last example. Okay, let's move into the last example. So the last example over here is bracket a over b to the bracket to the power m, right? And it is equal to a to the power m over b to the power m, right? Okay, let's do the checking one more time, the last time. Okay, since this is the last property, I think everyone does understand it. Okay, so we have a as 2 over here, and the 2 is a real number, right? 2 is a real number, right? So, and you can see over here is that we so a is equal to 2, and 2 is a real number, right? And then we got b equal to 5, right? 5 is also a real number. And keep in mind, in the condition over here, we have for any, right? Just any. So for any real number, so any real number, that means we can have as many as we want. We can have as many as we wanted, right? For any real number, any means it can be a, it can be b, right? And b over here is equal to 5, right? B over here is actually equal to 5. So you know it's valid, right? We does hit the condition, right? And then we over here we got m equal to 3. 3 is a positive integer, right? So you know the condition does hit it. And then so we don't have an n over here, so there's no requirement. We are not actually concerned about n, right? So you know we are actually able to perform the property, right? Okay. So let me zoom in a little bit, try to make things a little bit clear, I guess. Let's zoom in a little bit. So let's do this in the detailed way, okay? So we got 2 to the power 3 and then 5 to the power 3, right? Pi to the power 3. 2 to the power 3, if everyone remember, it's gonna be 8, right? And 5 to the power 3 is just equal to 125, right? Right? So it is gonna be 8 over 125, okay? And then, you know, always remember you have to keep the solution as simple as possible, right? But over here, I think 8 over 125 is already the simplest form. You cannot cancel any term, so we just leave the answer as it is, and this is the, okay, you just leave the answer as it is, and this is the question. I mean, this is the, you know, this is the answer for the example for, you know, for question 5, for property 5, okay, property 5. All right. So now let's move into the last part, okay? Just there are also some other really important thing, which is really important, okay? And okay, so basically over here we got the definition for the polynomial, okay? Polynomial is a really important topic. It's a really important topic because it's gonna continue further on. Alright, it's really important, so you guys definitely need to understand it. So the definition for the polynomial over here we have as an algebraic, so the definition of a polynomial, right, is an algebraic expression that can be written as a term. Okay, those are the keywords. A term, or as the sum or difference of terms. So those are the really important detail. You need to know it. So an algebraic expression can be written as a term. So it can be just a term, or it can be the sum or difference of terms. So more than one term, right? Okay. So let me give you guys some example. Okay, I'm just gonna write it down. Maybe over here. Yeah, I think it's just gonna write it down over here because we are lack of space. Okay. So the information I want to tell you guys right now is what is not a polynomial. Okay, not polynomial. Polynomial. Okay. So over here we know a polynomial is a term, or is the sum or the difference of terms, right? So terms means one more than one, right? So I'm just gonna tell you the thing which is not a polynomial. Okay, the thing which is not a polynomial. So for example, we got something like 1 over x, right? So you just kind of like memorize 1 over x is not a polynomial. Okay, and you also got something like maybe the root of the x is also not a polynomial. Okay, it's not a polynomial. So in those two cases, whenever you see 1 over x, that is not a polynomial. And whenever you see the root of x is also not a polynomial. Okay, so let me show you some terms. Okay, some terms. For example, maybe you have something like 2 to the 2x to the power 2, 2x to the power 2. Okay, and then you got plus another x, and then you plus 1 over x. So maybe you have something like, okay, x to the power 3, and then you have x, you got plus 1 over x. And you can see over here, as I mentioned before, a polynomial can be the sum or difference of terms. Right here, we got terms, right? We got a sum, and this is not a polynomial because we have a 1 over x over here. We have a 1 over x over here. So therefore, it is not polynomial. Okay, you guys get it, right? So if there's a term, it's not polynomial and it is in terms. Terms mean more than one. So it is involved in that terms, then it is not a polynomial, not a polynomial, no matter what. Okay, so if you see any of those terms in any of those terms in a terms, then those are not polynomial. Okay, so keep in mind. Okay, so we already talking about not polynomial. So maybe we should talking about what is a real polynomial, right? So let me so it's gonna be polynomial. Okay, so we already talking about the situation, the cases which is not polynomial. So maybe right now, we're talking about the it is a polynomial. Okay, so we're gonna have something like maybe 3x to the power 4, and then we got plus x to the power 3, and then we got a minus 2x. So now it's gonna be a polynomial. Okay, so this is gonna be a polynomial. Okay, so you can see over here just those are polynomial, right? So those are terms, right? So excuse me. So those are terms, right? So so basically those are terms, right? So those are actually terms, right? So this is gonna be a polynomial. Okay, so this is gonna be a polynomial, right? Excuse me. So okay, right? The definition. That's how a polynomial is, right? A term or the sum or difference of terms, right? So that's how how it's gonna work, right? Okay, that's how it's gonna work, right? Okay, so let's moving to some other the I think there's last 2 points I want to talk about. Last really important 2 points over here I want to talking about. So over here, what we got is the degree of the polynomial. Okay, the degree of polynomial is equal to the highest power in any one term. Okay, degree of polynomial is equal to the highest power. The highest power is the keywords. Highest power in any one term. Okay, so we got an example over here. So we can see the example over here is 5x to the power 4 minus 3x to the power 2 and then plus 4x. So as we mentioned before, the definition say it's gonna be the highest power, the power, right? Highest power in any one term, right? And then you can see the highest power over here is actually equal to 4, right? The highest power, right? So the highest power, let me rewrite a little bit. So the highest power you can see over here is actually 4, right? The 4. So you know the degree is equal to 4. Okay. Right. So the degree of the polynomial, maybe repeat it one more time. The depth is the highest power, right? Highest power in any one term, and then the highest power we got over here is x to the power 4, right? So degree is equal to 4, right? Okay. And with this one last thing, I think it's the most important thing in this section. So the coefficient, okay? Coefficient is just equal to the number of factory of a term. So for example, we got 3x over here. So 3 is going to be the coefficient, okay? The coefficient. Okay, we got 3x over here. So therefore, 3, the number before the variable is going to be the coefficient, okay? So you can see over here in the last example, we got 5x to the power 4 minus 3x to the power 2 plus 4x, right? So 5 is the coefficient and negative 3 is another coefficient, and then plus 4 is also another coefficient, okay? So maybe try to okay. So plus 4 is another coefficient. So remember, the coefficient is just the number before the variable, okay? So the coefficient is just the number, the number before the variable, okay? Okay. So I think we talked enough. The most of the really important property, or we already talking about. We already finished it, I guess. Yeah. I think everyone should understand pretty well, right? About those conditional stuff. The condition, how you actually gonna checking the condition to make sure you can using the property, and also the definition of the polynomial and the degree of the polynomial, and also the coefficient stuff, right? So I think right now we are actually ready to doing some questions. Okay, we are actually ready to doing some questions. So let's do the question in the fast way. So actually we got totally 8 question over here. Okay, we got totally 8 question over here. So maybe now is the time to skip it. If you feel like you can actually do those questions. I mean, if you think some of question is easy for you, then you just skip it. Okay. Otherwise, I will fully explain all the question in detail. Okay. Okay. So let's move into question 1. Okay. So question 1. Let me zoom in a little bit. Just wanted to make sure you guys on the screen. You guys only focus on this question right now. So as I said before, we got x, so let's do it in the fast way, okay? So since I think you guys are prepared for it, okay? So we got bracket x to the power 2 and then bracket x to the power 3. So you should right away you should know it's x 2 multiplied by 3, right? So as the property said before, right? It's as the property said before, right? So it's equal to x to the power 6, right? So you got x to the power 2 and then that's the thing, that's the power 3 outside the bracket. So it can be 2 multiplied by 3. 2 is which is 6, so x to the power 6, right? So we solve the question 1. Right, so we actually solve question 1. So over here we actually got 7 bracket 7 to the power 2 and then bracket to the power 4. So it's almost the same thing as the last question, right? So we have 7 and then 2 multiplied by 4, right? Is equal to 7. 2 multiplied by 4 is actually going to be 8. Okay, I think last question it's a little bit too fast. So right now we try to slow down a little bit. Okay, I want to make sure you guys does understand it. That's the main thing, right? So what we have right now is actually 7 to the power 8, right? So you can actually leave the answer at AS, or if you have a calculator, it will be much more better. So it will be much more better to using the calculator to find the answer of it. Okay, so 7 to the power 8 is actually a really big number. Okay, so I think right now we're just gonna leave the answer as 7 to the power 8 as it is. Okay, so if you're using the calculator over here and calculate 7 to the power 8, it's actually a quite really big number. So I think I think it's just better to leave the answer as 7 to the power 8. Okay, so we're done with question 1 and question 2. Okay, we just done with question 1 and question 2. So let's move into question 3. So question 3, what we got over here is simply bracket 5p q bracket to the power 3, right? So as the property we have it before, is just gonna be 5 to the power 3 p to the power 3 and then q to the power 3, right? So now we have to simplify a little bit. So we have to simplify 5 to the power 3 actually. So 5 to the power 3 is actually 125, right? So it's 125 t to the power 3 and then it's going to be q to the power 3. Makes sense, right? Okay, it makes sense, right? So we cannot actually doing anything more than this. So we just leave the answer as 125 p to the power 3 and q to the power 3. Okay, so let's do question 4. So question 4 is also kind of similar to question 3, right? So all we have to do is just multiply, right? So we got bracket 4x to the power 2 y bracket to the power 3, right? So we actually have to apply the property over here, right? And all the conditions have been met, right? Because 4 is a real number, right? 4 is a real number, and 3 is also a positive integer, so the condition have been met, right? So keep in mind, whenever you're applying the property, you always want to make sure the condition have been met. So here 4 is a real number, so the condition have been met, and then 3 is a positive integer, so we are good to using the property, right? So what we have is 4 to the power 3 and then x 2 multiplied by 3 and then y to the power 3, right? That's what we have. And then we need to simplify a little bit, right? Things make sense, right? So it's just gonna be equal to, for 4 to the power 3 is actually going to be 64, right? And then we have x 2 multiplied by 3 is actually going to be 6, and then y to the power 3, right? So everything makes sense, right? 4 to the power 3 is actually 64, and then 2 multiplied by 3 is going to be 6, so x to the power 6, y to the power 3, right? Okay. So we're done with question 3 and 4, okay? Now we're done with question 3 and 4. Excuse me. Okay, we're done with question 3 and 4. So let's moving to let's move into question 5, I guess. Now things get a little bit more steps, right? A little bit more steps. So we have to, as I say before, we always have to get rid of the bracket first. We have to get rid of the bracket, right? We got 2 brackets over here, so we have to get rid of it, right? So how we get rid of it? We have to using the property, right? So you want to make sure, like, you does, right? You want to make sure, like, you does, right? You want to make sure, like, you can actually using the property over here. So so what we have on the right hand side, we have a bracket 3m to the power 2, and then bracket to the power 4. 3 is a real number, right? And then 4 is actually an integer, right? I mean, it's a positive integer. 3 is actually a positive integer. And on the right hand side, we have a negative 2, right? But we have a negative 2, right? So we have a negative 2. That's real number, right? That's actually a real number, right? That's a real number. Negative 2 is actually a real number, right? Okay, don't get confused over here. Okay, don't get confused over here, because negative 2 over here is actually a, right? So negative 2 over here is actually a, and the requirement for a is a real number, right? Any real number a, as the condition we said before, right? A is only the condition for real a. I mean, the condition for a is real number, and negative 2 is a real number, right? And then we have a 2 over here, so 2 is a positive integer, right? So the condition have been met. Don't confuse, okay? Don't confuse. I mean, you know negative 2 is actually negative integer, but the condition what we needed for a is a real number, okay? It's a real number, and negative 2 is a real number. So the condition does meet it, okay? Right? So now we are actually able to apply it. Okay, we are actually able to apply it. So we have 3 to the power 4, right? So we have 3 to the power 4, and then n is just simply equal to 2 multiplied by 4, right? It does that, right? 3 to the power 4, and then 2 multiplied by 4, right? And then we got the multiplication, right? We got the multiplication over here. Let me show you the step one by one, okay? So on the right hand side, we got negative 2. We saw negative 2 and there's a power 2, so it just becomes negative 2 squared. And then we have multiply n 3 multiplied by 2, right? We have n 3 multiplied by 2. That's how we're using property, right? And then we have to simplify a little bit more. So we got on the left hand side, we have 3 to the power 4. 3 to the power 4 is actually 81, right? It's actually 81, right? It's actually 81, right? So basically, 3 to the power 4, it just becomes 3. So it's 3 to the power 4, it just becomes 3 to the power 2 multiplied another 3 to the power 2, and 3 to the power 2 is actually equal to 9. So 9 multiplied by 9 is 81, right? And then we got m equal to 2 multiplied by 4, which is 8, right? And then we multiply negative 2 to the square is actually 4, right? 4m 6 3 multiplied by 2 is actually equal to 6, right? So now we have to multiply things all together. So we got 81 multiplied by 4, right? We got 81 multiplied by 4. So 81 multiplied by 4 is actually gonna be 324, right? So 81 multiplied by 4 is actually 324, right? And then we got those two variables, right? 8 m to the power 8 multiply m to the power 6, so it just becomes 8 plus 6, right? So that's the property, you know, I think everyone know it, right? So m to the power 8 multiply m to the power 6, so it just becomes m to the power m plus 8 plus 6, right? 8 plus 6. So I think we are on our last step, so it becomes 324 8 plus 6, it just becomes 14, right? So 8 plus 6 is equal to 14, right? So now we finish the question, right? I hope there's nothing confused right now, okay? So the only confusing part is maybe just this part, but I already fully explained it. As I said before, when you look at -2 over here, let me repeat it one more time, I guess. When you look at -2 over here, -2, you see -2 as a, okay? You see -2 as a, and what we have for the condition of a is a have to be a real number, right? A have to be a real number, and -2 is a real number, right? Real number, right? So you actually don't need to confuse. There should be no confusing. Even you see -2 is a negative number. It is not a positive number, but it is not a positive. It's not a positive number, but over here, a -2 is actually a, okay? And the only requirement for a is a real number, right? And real number actually include negative number and also positive number, right? Right? So you guys know it, right? Real. Let me write it down. Real number is actually real number include positive number and negative number, right? Okay, you guys get it, right? So the only requirement for a is a real number, and a real number include positive number and the negative number. So you know the condition is fully met, right? Okay, the condition is fully met. I think I think everyone should understand it right now, right? Okay. Right, so let's move into question 6. So question 6, I think, okay. So question 6 we have is bracket to the power 5 bracket to the power 3 and over to the power 6, right? So we have to simplify the numerator first, right? We have to simplify the numerator first. So we have bracket to the power 5 bracket to the power 3. So we got 5 multiplied by 3, right? 5 multiplied by 3 over to the power 6, right? So the next step we have to simplify a little bit, right? So 5 multiplied by 3 is actually 15, right? 15 over to the power 6, right? And it just equal to as the property say it, right? As the property say it, equal to 15 over 6. It just equal to 15 minus 6. That's the property say it, right? That's the property say it. So we have to the power 15 over to the power 6. So everything, all the conditions have been met, cause, right? All the conditions have been met, cause over here 15, both 15 and 6 are positive integer, right? So we are actually able to using the property. So 15 minus 6 is actually equal to the power 9, right? So the answer for question 6 is actually to the power 9, right? Okay. So yeah, so let's move into question 7. So I think up on this point you guys should understand it, right? Why you want to make sure, like, when you using when you all the time or when you using the property, okay, let me write it down, okay. When you solving this kind of problem, the step one is always gonna be checking the checking the condition is valid or not. It's valid or not valid. Okay, after that, step two, then you just step two, if it is valid, then you solve the question. Then you solve the question, you know, and using the property, okay, using the property. So basically, you know, the trick how you actually the trick. Well, let me tell you one trick. Actually, how you actually you know, using those properties. Okay, so you can see in this question 7 we got y to the power 5 and to the power 3, right? And then we got bracket y to the power 3 and bracket to the power y to the power 2 as the numerator, right? And on the denominator we have y to the power 4 to the power 4, and then you can see all of those numbers is actually positive integer. So you right away you should know you are able to use the property, right? And if you practice enough, you know, like me, then you know, without any hesitation, you should able to solve it right away. You don't actually think too much, you know, when you actually know it. Like if you practice many times, then when you all the time you seeing the question, you already know you are good to go. You know, you are actually you know you right away you should know how to solve the question without any hesitation, thinking about, like, you know, does the condition that's made it or not. Okay. So if you practice a lot and you know, if you're good enough, you should able to see when you see on the moment when you see the question without any hesitation, you should know, you already know, you know, yeah, you are actually able to solve the question. You don't even thinking about, you know, that the condition doesn't need it or not, because you're already assuming, you know, yeah, you can actually using it. Okay. So that's you know, if you practice enough, if you practice a lot those kind of questions, then you should be able to do it really fast. Like maybe 10 seconds you are done. Okay, maybe not that fast. Maybe 15 seconds you are done. Okay. So we had. I'm still going to show you the details. Okay. So let's solve the numerator part first. Okay. So what we have is y 5 multiplied by 3, right? And then we have multiply y 3 multiplied by 2, right? 3 multiplied by 2. And then on the denominator what we have is y 4 multiplied by 4, right? So now we have to simplify a little bit. It's equal to y 5 multiplied by 3 is actually 15. Multiply y 3 multiplied by 2 is actually 6, right? And then what we got over here is y 4 multiplied by 4 is actually 16, right? 4 multiplied by 4 is actually 16, right? So now we have to simplify a little bit more. So at the top we got y to the power 15 multiply y to the power 6, right? So right away you should know is 15 plus 6, right? And the denominator is still y to the power 16, right? So we have to simplify a little bit more, right? So what we have is y 15 plus 6 is actually equal to 21, and then over y to power 16, right? Y to the power 16. So now we actually, you know, we almost solve it, right? So it is equal to y. So as the property say before, it's gonna be y to the power 21 minus 16, right? So it's just going to be y to the power 5, right? So it's going to be y to the power 5. You guys get it, right? So y to the power 21 minus 16 is actually equal to y to the power 5. And that is the solution for question 7, right? That's the solution for question 7, right? Okay. So let's move into question 8. So since question 8 is the last question, so maybe pause the video and try to solve it by yourself and see that you get the right answer, right? Okay, so pause the video. Okay, so now it's the time we're gonna doing this question. So I think maybe I'm gonna show you one time how you doing those questions really fast without any hesitation. Okay, so first of all I'm gonna show you the fast way. Okay, the fast way, and then after that I have to show you the detail, because maybe some people feel like it's too fast, they don't understand it. So okay, so the first is the fast way to doing this kind of question. Okay, so let me erase it. So let's talking about it. Okay, so we have, so let me first say the question first. So it's bracket x to the power 5 y to the power 2 over z to the power 4, right? Bracket everything to the power 3, right? So basically what we have to do over here is just something like this. Okay, so z to the power 4 to the power 3, and then we have to simplify a little bit. So x 5 multiplied by 3 is 15, y 2 multiplied by 3 is gonna be 6, right? So y, it's gonna be 6, right? And then we got z over here is 12, right? So 3 multiplied by 3 is actually 12, and then we're actually done with this question, I guess. Okay, I think we're actually done with this question, because we cannot simplify anything more, and we got 3 variables over here, x, y, z, and none of them, all of them are different. We cannot simplify anything more than this, right? Because all of them is different. We are not able to cancel anything right now, right? So we just leave the answer as x to the power 15, and then y to the power 6 over z to the power 12, right? So z to the power 12, that's how we actually gonna solving the question, right? So as you can see over here, we are actually not able to simplify anything more, because we got three variables over here, x, y, z, and then this already the simple is the form, right? Okay, so maybe I'll show you the detail way, details. Okay, so the detail, if you actually solving this question a little bit detail, just want to make sure like you guys does understand it. Because maybe some people just don't understand it, so I have to explain those in details. So remember the property before, right? So basically over here, let's check the condition one last time, right? Okay, let's check the condition one last time. We got x power 5. 5 is a positive number, right? 5 is positive number, and y to the power 2 is also another positive number, and then we have over c to the power 4. 4 is another positive number, right? And then we have everything to the power 3, right? Everything to the power 3. 3 is also a positive number, so we everything is valid for the property, so we are actually able to do it. We are actually able to use property, right? So you should know that since we have a bracket, so we have to get rid of a bracket. We have to get rid of the bracket, right? We have to get rid of the bracket in order to solve the question. So how we actually get rid of the bracket is just basically because x to the power 5 and y to the power 2 and z to the power 3, right? Because we have everything to the power 3, right? We have everything to the power 3, and this is one of the property. So it just be this one of the property, right? So we have x to the power 5, y to the power 3, we have x to the power 5, y to the power 2, add 2 to the power 3, right? And then on the bottom we have z to the power 4 bracket 2 to the power 3, right? And then now we have to simplify a little bit more. So we got x 5 multiplied by 3, right? So 5 multiplied by 3, and then multiply y 2 multiplied by 3, right? And then we have the c we have on the denominator, we have z to the power 4 and then multiplied by 3, right? So now we are actually solving the question, right? So we have x 5 multiplied by 3 is 15, right? And it's equal to y 2 to the power 3 is actually equal to 6, right? And then we have over z x to the 4 to the power 3 is actually equal to 12, right? So you can see the answer is the same, right? So the answer is actually the same thing. So the answer for question 8 is actually x to the power 15 multiply y to the power 6 and over z to the power 12, right? So z to the power 12. So that's actually how you solve the question, right? That's how you actually solve the question, right? Okay, so I think this is everything for today's video. Okay, so on today's video we actually talking about at the beginning we're actually talking about today's topic is exponent and polynomial, right? So as I said before, it's just really important topic. You guys have to know it, right? So we actually, to summarize it, we actually talking some really important property, and we mentioned the condition, right? So condition, you always have to check in the condition all the time when you actually apply it, right? So it's okay, so the condition, right? So why you actually, we always have to check it when you actually apply it. So we're talking about the five most important property, right? We're actually talking about 5 important property, right? And after that we have actually talking about the definition of the polynomial, and then I just give you guys about some example, right? I gave you guys some example of which is not a polynomial, right? Which is not a polynomial, right? Which is not a polynomial, and which is a polynomial, right? Which is a polynomial, right? And then after that we're talking about the degree of the polynomial, the degree of the polynomial and coefficient, right? And after that we're talking about those questions, right? So we're basically talking about those questions, right? So we're basically talking about those questions, right? So I hope, so thank you guys watching this video. Please like the video and click the notification. I will keep uploading video, okay? And then if you still have anything which is confusing you, and anything, or maybe anything you want to say to me, then please leave a comment below, okay? Okay, good luck with your exam, and then see you guys on the next video, okay? See you guys on the next video.